So solving simultaneous equations means finding the point or the points between two curves or lines where they meet, where they cross each other. And we're going to do this algebraically, so that means not using graphs and not using pictures or anything like that, but actually just using the algebra that's in front of us. And we're going to solve this by using a method called elimination. So what we're going to do is get rid of one of the variables, x or y, find out the value of the other one, the one that's remaining, and then use that to find the value of the y or the x. But the first thing I'm going to do is I'm going to draw these two graphs. Okay, so there are no powers of x other than a 1. So it's just an x, there's nothing there. So I know these are two straight lines, these are linear graphs, so they're going to be straight lines. Okay, the gradient of this one is 3, and the y-intercept is a 2. So I know that this graph crosses at y equals 2, and for every 1 along, I'm going 3 up, so my next point is there. Which means that if I go 1 back, I must go 3 down, next point is there, 1 back, 3 down. Got a few points now, and I can draw a straight line through those. You have to forgive the straight line there. Okay, in this one, the gradient, the number in front of the x is 1, and the y-intercept is a -6. So I know that my graph is going to cross through at -6. There's -1, 2, 4, 5, and -6. And for every 1 along, I'm going 1 up. So I've got a nice straight line. Much shallower gradient, but that's what we would expect with a gradient of 1 compared to a gradient of 3. And it does mean actually that this graph is crossing the x-axis at 6. And the reason for that is when y is 0, we're going to end up with 0 is x minus 6. So something, take away 6 is 0, so that something must be 6. Okay, so we've drawn our two graphs, and we can see that they're converging, they're coming to meet at some point. But I don't think I could work out that point without really having drawn that very, very accurately. And also, what happens if it disappears off your graph? So this is why we use the algebra, so it means we don't have to draw some massive, massive graph. But we can find this one point where these two lines cross. Okay, so as I said before, we're using a method called elimination, which means we need to eliminate one of the variables. We need to get rid of it. Now, my temptation would be to get rid of y, because in this case, we've just got one lot of y. Now, we use a little trick where we take away down. So the first thing is to make sure that our two equations are written in this form, one on top of the other, and normally we'll label them 1 and 2. Then we tell ourselves what we're going to do. We're going to take equation 2 away from equation 1. So I'm going to take all my y's away from the other y's, x's away from x's, numbers away from numbers. So we're going to have 1 subtract 2. Okay, so y take away y is nothing. 3x take away 1x is 2x. And 2 minus, or take away, minus 6. So 2 minus minus 6 is plus 8. So we're going to end up with that. Okay, now this is just a little linear equation, so you can solve that. It should be 2x is minus 8. So what I've done here is I've taken 8 off both sides of the equation. Don't forget to take it off both sides, because otherwise you don't leave your equation balanced. So then x must be minus 8 divided by 2, which is minus 4. So all I've done here is divide both sides by 2, because I want to get at x on its own. Okay, so we know that of this point that we found, remember we had two graphs crossing and we knew we had a point where they crossed, that point must have an x-coordinate and a y-coordinate. It's one point on a graph. And we now know that that x is minus 4. What's y then? Well, to find out y, we substitute, or sub, x is minus 4 into one of the two equations. It doesn't matter whether it's y or x. 1 or 2, sorry. I think I'm going to substitute it in 2, just because it looks like a simpler equation. So substitute x equals minus 4 into 2. So we don't know what y is, so we can leave that as y. Is equal to x. Well, we know that x is minus 4, so let's put minus 4 there. And then we've got minus 6. So y is equal to minus 10. So on that point where those two graphs are crossing on our first part of the video, the x-coordinate is minus 4 and the y-coordinate is minus 10. And the way we got that was by eliminating one of the variables. So in this step here, these steps here, we got rid of y. But we haven't forgotten about it completely. We wanted to find the value of y here. Okay, but what happens if we've got multiple y's? So here we've got 7y and 4y. Well, luckily in this example, our x's are the same. So I think we need to eliminate x. Okay, so set our equations as 1 and 2. And I think, well, okay, I want to get rid of the x's. And I've got a minus 3x and a 3x, a plus 3x. What do I have to do? What do I have to add or subtract to get no x's? I think if I've got minus 3x and I add 3x, I'm going to get 0. So minus 3 plus 3 is 0. So I think I need to add these two expressions together, which means I need to do the first equation, add the second equation. In the previous example, we had to take them away because we had a positive y, so we needed to take away the other positive y. In this case, we've got minus 3x, so we need to add the 3x to get rid of it. Okay, so we're adding the first equation to the second equation, but we're adding down, don't forget. So 7y plus 4y is 11y. Minus 3x plus 3x is 0, 3x. Fantastic, so we can just leave that off. It was exactly what we wanted to do. We wanted to eliminate x. And 10 plus 12 is 22. So if 11y is 22, 1y must be 2. Brilliant. So if that coordinate that we were trying to find, because that's what we're wanting to do when we solve simultaneously, the y value is 2. But what about the x value? So let's substitute. We're going to substitute y is 2 into one of the other equations. I'm going to choose 1 this time. So 7 lots of 2, so 7 lots of y, minus 3 lots of x, give us 10. So 14, so 7 times 2, minus 3x is 10, which means that minus 3x is minus 4, so x must be 4 over 3. Don't forget I've got a minus and another minus I'm dividing, so minus divided by minus is a positive. So that means that the x value of this coordinate is 4/3. Okay, so final example then. In this case though, our equations aren't written so that we've got y's on top of one another and x's on top of one another. It's all in a bit of a funny order. So I think my first step is to write those expressions as I recognise them. So rewrite the expressions, or the equations. Okay, so I'm going to put y's first, I tend to like that. So 4y plus 5x is 13. That's our first equation. And 8y plus 3x is 5. That's our second equation. All I've done is I had 5y plus 5x plus 4y, and what I've done is done 4y plus 5x. And we know that when we're adding together, we can switch those two numbers around. That's not a problem. Okay, but I haven't got the same number of y's or the same number of x's. So if I just take away 1 or 2 from the other equation as it stands, I'm not going to I'm not going to eliminate either of my variables. So what I need to do is multiply one of my equations by a number so that I get the same number of y's or the same number of x's. So I've got two choices. Either I multiply the first equation by 3 and the second equation by 5, and what that would do is give me 15x in both cases. If you don't believe me, try it. Or I can just multiply the first equation by 2. And I think because that's a lot simpler, I'm going to do that. So If I multiply everything in the first equation by 2, I'm going to get 8y plus 10x is 26. Now be really careful when you do that, because it is so easy to get a sign wrong if you've got minus signs, or to forget to multiply one of these expressions by the 2 or the 3, whatever your number is. And then the last thing I'm going to do is I'm going to relabel this 3. So I remember it's not one of my original equations, but it's an adaptation of it. I'm then going to write 2 underneath it, because I now have 8y in both equations, so I don't need to do anything more. And that was 2, wasn't it? Okay. If I do 3 take away 2, I'm going to get rid of my y, so I'm going to eliminate my y, which is brilliant. So equation 3 take away equation 2. Well, 10x take away 3x gives us 7x. Don't forget our y's have disappeared. 8y take away 8y is gone. And then 26 take away 5 is 21. So x must be 3. So in that equation then, that point we were trying to find, that coordinate, our x value is 3. Now we need to substitute x is 3 into one of our original equations. So this is why we labelled this new one 3, because it isn't one of our originals. I am going to substitute that into equation 1. But don't forget you can pick either. So 4y plus 5 lots of x, which is 5 lots of 3, so that's 15, is equal to 13. So 4y is minus 2. I've taken 15 off both sides. So y is minus 2 over 4. Don't forget that over 4 means divide. And that's a fraction, so I can cancel that down. That's minus a half. So the y value of this coordinate we've been trying to find is minus a half.